Good morning, everyone, and happy Monday. I'm sorry I couldn't be with you today. I am at jury duty. I'm hopeful I'll be back tomorrow. So we're going to have you guys kind of work on the next lesson on your own. And then whenever I come back, like I said, hopefully tomorrow, I can answer any questions and we can clarify anything that maybe you don't understand. So we're going to continue on with Beyonce, picking up kind of from what we did on Thursday. So this is lesson 3.3, which is the Beyonce part 2. First thing says to copy the class dot plot from the notes from yesterday, the random sample one, not the convenient sample. So I went back to my notes and this is the dot plot. It should also be hanging on the wall in the classroom underneath my bulletin board if you wanted to kind of look at that. Remember that we had a true mean value of 3.53 when we looked at those dot plots, and the actual average length of the Beyonce song was 3.53. So what I'm going to have you start off by doing is in your small groups, so groups of 2 or 3 like we usually do, what I want you to do is I want you to work on this first page of the lesson. When you get to number 4, where it says to take a random sample, I want you to take 2 random samples of size 10. Okay, using the random number generator. And I'm asking you to take 2 of them so that we have more dots on the dot plot. And you can do one of 2 things. You can either take my dot plot that we had created the other day, the one under the bulletin board, and hang it up on the dry erase and put your dots onto the second plot on the bottom. Or what we can do is just put them on the dry erase board, someone make a number line, and then y'all go ahead and put your dots on that, okay? You're going to have to work together to get this done, and I'm trusting that you're going to be able to do that, okay? So when you get to number 4, remember you're taking 2 random samples of 10 words. You're going to find the average of your sample and put it on the dot plot at the front, however you guys choose to do that. Once everybody's got their 2 random samples and their averages plotted on the dot plot, you're going to copy the dot plot here and then finish by answering question number 5, okay? So take somewhere about maybe 10 to 15 minutes to get this done. And then once you have that done, again, you guys have to all work together to make this happen, okay? Once you have that done, then come back to my video. Excuse me, and you should be able to kind of go over everything through the video, okay? Come back to me in a few. Okay, first thing we're going to do is we're going to look at number 2. So it says describe in words the process that we used last time to select a random sample. So basically what we did was we gave each word a unique label from 1 to 297. This was technically already done for us on the paper that I gave you. Then we randomly generated 5 numbers using the random number generator, and we ignored anything that repeated itself. Then we used the 5 words that we selected corresponding to the, use the 5 words that correspond to the numbers we selected as part of our sample. So if we were to try to use this same process, but by putting names in a hat, basically what we would do is we would write down each word of the song Crazy in Love on a slip of paper, making sure that all of the slips are the same size. Then we would put the papers in a hat and mix it well. And then we would select 5 slips of paper and use those words as our sample. Okay, so again, what I want you to do is I want you to then take, or you should have taken 2 random samples of 10 words from the song Crazy in Love, finding the average of the sample and putting it on the new dot plot that we're creating at the front of the room, however y'all decided to do that, okay? So you'll have some sort of dot plot here. I obviously can't put it in this video because I don't know exactly what it looks like, but I'm hopeful that if we've done this properly, the variability in this new dot plot will have decreased, meaning that it's not as spread out, or the points are not as far apart as they were in the first one, which we put up in number 1. So with the variability decreasing, basically what's happening is that our estimates are getting closer and closer to that true value, which is the 3.53 that we know based off of the actual analysis of the song. Okay, so hopefully you guys were able to get that part done on your own. And now we'll move over to the important ideas from this particular section. So our first important idea deals with the simple random samples, which is what we took the second time we took a sample on Thursday, and then also today. So simple random sample is often abbreviated as SRS. So if you see SRS written somewhere, it's referring to a simple random sample. Now, there are basically two ways to take the simple random sample. The first thing would be to use, like we did, the random number generator. And sometimes we abbreviate that as an RNG, okay? And in order to do that, an important thing to remember is to ignore anything that happens to repeat itself. So when you're describing how you would take a simple random sample using a random number generator, the most important thing you have to remember to do is talk about how you ignore the repeats. Actually, with both of these methods, super important that we always label first. So those labels are either the numbers in the random number generator, like the numbers you're going to use for each word in this case, or for each object. In the case of the slips of paper, the labeling would be writing down whatever it is on an independent slip of paper. Okay, so for our slips of paper, other than the labeling, of course, an important thing to remember is that the papers have to be identical in size, identical size papers. And we have to remember to mix well, okay? That's part of what allows us to use this simple random sample idea, okay? The second thing that we want to talk about in this particular section deals with sampling variability. So all of us took samples that were the same size, and it would be very rare for us to get the exact same numbers, you know, each one of us. Each of our samples is a little bit different. So some of them are going to give us estimates that are too high, and some of them are going to give us estimates that are too low. The hope is that we're able to get as close as possible to the actual value that we're hoping to calculate. So let me write this down for us. So each sample is different. Some give estimates that are too high, others too low. Now that variability is going to happen because we're choosing different samples. They're all a little bit different, so our estimates are going to be a little bit different. Again, we're hoping that we can kind of get close to that actual true value, which is what we're looking for. So often when our goal is to decrease the amount of variability, the best way for us to do that is to increase the size of our sample. Okay, so that's why when we started with the samples of size 5, we got a certain amount of variability. And then when we took samples of size 10, we should have seen a decrease in the variability. Okay, so the points again should have been closer together. It should have been getting closer to that actual value of 3.53. Okay, hopefully they're not as spread out. Again, I can't tell you exactly what you're looking at because I don't have it in front of me. So what I want you to do now is I want you to take a look at these application questions, take a few minutes and go over them with your partner, with your small group. Pause the video while you're doing that, and then come back and kind of check your work with what we're doing here, okay? All right, so thinking about our school has about 1,700 boys, right? So the question is, what proportion of students at your school use Twitter? To find out, you decide to survey a simple random sample of students from your school. In the sample of 50 students, 76% say they use Twitter. So how could you select a simple random sample using a random number generator? So remember, the first thing we need to do is label. So we would give each student a number. And we'll start from 1 and run up to 1,700 or whatever the actual number is here at Columbus. It's somewhere around that, right? So using a random number generator, to select 50 numbers from 1 to 1,700, ignoring repeats. Okay, that was one of the things we said we needed to remember to do. And then we would survey the students whose numbers were chosen. Okay, so we label, we randomly generate ignoring the repeats, and then we select the students that were chosen based off of that sample. Okay? 2 says, will your sample result, 76%, be exactly the same as the true population proportion for all students? And the idea here is, remember that we said that there is sampling variability. So the answer will be no, because random samples produce different proportions. It's unlikely that we're going to get exactly the same number. Okay? Okay, and then the third question says, which would be more likely to yield a sample result closer to the true population value, an SRS of 50 students or an SRS of 100 students? And so, of course, here, remember we said that increasing the sample size reduces the variability. So the answer would be an SRS of 100 students, because increasing the sample size reduces variability. Okay, so hopefully this lesson went pretty well. I'm hoping, like I said earlier, I'll be back tomorrow, and then I can answer any specific questions for you. We can talk about this, we can go over it. If there's something that's really bothering you and you need to ask me sooner rather than later, please feel free to send me an email, and I'll do my very best to get back to you as quickly as possible. Not sure what my day will look like, so just be patient with me. And I would suggest trying to work on your homework assignment. That way we know kind of where we're at in terms of moving forward tomorrow, okay? Thanks, and I hope you've had a great day.